Mixture problems. These are a fairly common category of word problems that can be solved by two variables and two equations. So in this example, we're mixing Colombian and French coffee, and we're going to set up a table with the two components of the mixture and the mixture always at the bottom. So we should always put the mixture last. And then our column labels will vary a little bit from one problem to another, but the first one is almost always some form of amount. And the last one is often some form of total. And if we look at this cost in dollars per pound in the middle, let's see, our total cost is in dollars. It's always true that it's the ratio of the two units. So cost is in dollars, amount is in pounds, and cost per pound is in dollars per pound. So let's go ahead and start filling in the values that we know exactly. Colombian coffee costs $9.20 per pound, so the cost per pound of Colombian is 9.25. French roast costs $11.50 per pound, so the cost per pound of French roast is 11.50. Roland mixes these two to create 4 pounds of a blend. That's the amount of our mixture is 4. And that costs a total of $42.50. We have to be a little bit careful about these numbers because the cost per pound often resembles the total cost in units. They can each be described in dollars, but this is clearly a total cost. This is not a cost per pound. For one thing, it would have to be in between $9.25 and $11.50 for this to be a cost per pound. And we're asked how much of each does he use. So we're asked for the amount of Colombian and the amount of French, which means it's reasonable to go ahead and put variables in these two spaces. Now, the way we finish filling in this table is that we multiply across to get the total cost. This is why it was important for us to set these up in exactly this way, where the cost in dollars per pound is sort of a ratio of the outer two units so that it makes sense to multiply the number of pounds by the dollars per pound to get the total dollars. So multiplying across, x times 9.25 gives us 9.25x. Y times 11.50 gives us 11.50y. And since we already have an entry for total cost, we don't really need this other one that's missing. The middle column is only there to help us fill in the other columns. It's usually not a value that we need to have an entry for every location. Now we're ready to set up our equations. And to set up our equations, we always take the first column amount and get one equation from that. The total pounds of Colombian plus the total number of pounds of French should give us the total number of pounds of the mixture. So x plus y equals 4. And then looking at our total cost, it's also true that the total amount of money spent on each Colombian and French should add up to the total amount spent on the mixture. So this gives us the equation 9.25x plus 11.50y equals 4240. And this is our two equations in two variables. We don't make an equation out of the middle column. We never do, because these are not additive. There is a relationship here, but it's more true that the mixture would be some sort of weighted average of the costs per pound of the other two, and that would be a little too complicated of a relationship. So it's much easier to just make our equations out of the first and last column, and that does give us enough equations. And that's the same reason we weren't concerned about not having an entry for that last row in the middle column, because we're not going to use the middle column to make an equation anyway. We only fill in an entry there if we need it to figure out our total cost. So now we have two equations in two variables. Let's go ahead and write those down again so that they're a little bit neater off to the side here. We have x plus y equals 4 and we have 9.25x plus 11.50y equals 42.40. This can be solved by substitution or elimination. I find elimination to be just a little bit easier. So I'm going to choose to target x. It doesn't matter much which one you choose to target, but usually if you choose the one that has a smaller coefficient, you're going to keep your numbers positive as you're going through the computations. So it does make it slightly easier. And I'm going to do that by multiplying this top equation by negative 9.25, so that I get negative 9.25x minus 9.25y equals 4 times 9.25 is going to be negative 37. I'll go ahead and write that as 37.00 so that it'll line up with the term I'm trying to combine it with. And next I write down the second equation with no change. 9.25x plus 11.50y equals 42.40. So that the x's drop out, and I combine the y's to get 2.25y equals, and I combine over here to get 5.40, and then when I divide both sides by 2.25, this would be a good time to bring in a calculator, although you may have brought one in already at this stage. I get 5.4 divided by 2.25 equals 2.4. So my y is equal to 2.4. All right, so we're not quite done, but we're getting pretty close. I'm now going to come back up to the table and say it looks like we found our value of y, which is 2.4. I can find x by formally substituting back into one of these equations, but it's often not necessary because we know that x plus y is 4, so it seems reasonable that 4 minus y is going to equal x, so I can just subtract this from the amount of the total mixture to get 1.6. And these mixture problems follow a similar enough pattern that we can do that pretty much every time. So I'm going to express my final answer here as 1.6 pounds of Colombian and 2.4 pounds of French. So make sure that you always remember to express your answer with units and with the appropriate labels. It's important that we know that 1.6 is measured in pounds and that the 1.6 goes with Colombian. The 2.4 is measured in pounds and that it goes with French.